Hash the future of space exploration, venturing beyond our cosmic backyard. Greetings, fellow cosmic adventurers, and welcome to another enthralling episode of Sci Discovery Chronicles. I'm your host, and today, we're embarking on an extraordinary journey that will take us to the very edge of human knowledge and beyond. Our destination, the awe-inspiring future of space exploration, with a particular focus on what lies beyond the familiar boundaries of our solar system. For centuries, humanity has gazed up at the night sky, wondering about the nature of those twinkling points of light and dreaming of one day reaching them. From the ancient astronomers who mapped the movements of planets to the pioneering scientists of the space age, our species has been driven by an insatiable curiosity about the cosmos. And now, as we stand on the threshold of a new era in space exploration, that curiosity is about to take us further than we've ever gone before. Let's begin our journey by reflecting on how far we've come. Just over a century ago, the idea of leaving Earth's atmosphere was the stuff of science fiction. Yet, in the span of a few decades, we went from the first tentative steps into space to landing humans on the moon. We've sent robotic explorers to every planet in our solar system, landed rovers on Mars, and even visited comets and asteroids. Each of these achievements once seemed impossible, yet they're now part of our shared human history. But as impressive as these accomplishments are, they're just the beginning. The true frontier of space exploration lies beyond the orbits of Neptune and Pluto, in the vast, largely unknown expanse of interstellar space. This is where our story truly begins. Our first stop on this cosmic journey is the fascinating world of exoplanets. These alien worlds, orbiting stars other than our Sun, represent one of the most exciting frontiers in modern astronomy. Just 30 years ago, we hadn't confirmed a single planet outside our solar system. Today, thanks to missions like NASA's Kepler Space Telescope and the ongoing TESS Transiting Exoplanet Survey satellite mission, we've discovered thousands of exoplanets, with more being found almost daily. These discoveries have revolutionized our understanding of planetary formation and the potential for life in the universe. We found giant hot Jupiters orbiting perilously close to their stars, super-Earths that dwarf our home planet, and even entire systems of planets that dance in orbital resonance. But perhaps the most tantalizing discoveries are those of potentially habitable worlds. Imagine for a moment a planet orbiting a red dwarf star, bathed in a constant crimson twilight. Its surface might be covered in vast oceans, with continents of bizarre alien geography. Or picture a world with two suns, where the interplay of light and shadow creates patterns we can scarcely imagine. These aren't just flights of fancy, they're based on real exoplanets we've discovered. The next leap forward in exoplanet research is already underway with the James Webb Space Telescope. This incredible instrument, the most powerful space telescope ever built, is capable of analyzing the atmospheres of distant exoplanets. By studying the chemical signatures in these atmospheres, scientists hope to detect potential biosignatures, telltale signs that could indicate the presence of life. But finding potentially habitable worlds is just the first step. The ultimate goal is to visit them, to see these alien landscapes with our own eyes. This brings us to one of the most challenging aspects of future space exploration: interstellar travel. The distances involved in interstellar travel are mind-boggling. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. With our current technology, it would take tens of thousands of years to reach even this closest star. Clearly, if we're going to explore beyond our solar system, we need to develop radically new propulsion technologies. One of the most promising concepts for interstellar travel is the idea of light sails. This technology, which is already being developed by projects like Breakthrough Starshot, uses the pressure of light to propel a spacecraft. The concept is deceptively simple. A large, ultra-thin sail is attached to a tiny probe. Powerful lasers are then used to push the sail, accelerating it to a significant fraction of the speed of light. The potential of this technology is staggering. Breakthrough Starshot aims to send a fleet of these miniature probes to Alpha Centauri, making the journey in just 20 years. If successful, this would mark humanity's first true step into interstellar space. But light sails are just one of many innovative propulsion concepts being explored. Another intriguing possibility is nuclear propulsion. While the idea of nuclear-powered spacecraft might sound alarming, it actually offers one of the most efficient and powerful forms of propulsion we've yet conceived. Nuclear thermal propulsion, for instance, uses a nuclear reactor to heat a propellant, typically hydrogen, to extremely high temperatures. This superheated propellant is then expelled through a nozzle, providing thrust. This technology could potentially cut travel times to Mars in half, making deep space exploration much more feasible. Even more exotic is the concept of antimatter propulsion. Antimatter, the mirror image of normal matter, releases enormous amounts of energy when it comes into contact with regular matter. A spacecraft powered by antimatter could potentially achieve velocities close to the speed of light. The challenge, of course, is producing and storing enough antimatter to power such a craft, but research in this area is ongoing. As we push the boundaries of propulsion technology, we are also developing new ways to sustain human life on long-duration space missions. The journey to even the nearest star would take years, if not decades, with current or near-future technology. This poses significant challenges in terms of life support, psychology, and even reproduction in space. One solution being explored is the concept of generation ships, enormous, self-contained spacecraft that could sustain entire communities for centuries. These ships would carry everything needed to support human life, including agriculture, manufacturing, and even ecosystems. The idea is that multiple generations would live and die aboard these ships during the long journey between stars. Another approach is the development of advanced hibernation or suspended animation technologies. If we could safely place human beings in a state of deep hibernation, we could dramatically reduce the resources needed for long-term space travel. While this might sound like science fiction, research into therapeutic hypothermia and other forms of metabolic suppression is already underway. Of course, as we look to the stars, we mustn't forget the incredible opportunities for exploration that still exist within our own solar system. The moons of Jupiter and Saturn, in particular, offer some of the most promising environments for potential extraterrestrial life. Take Europa, for instance. This icy moon of Jupiter is believed to harbor a global ocean beneath its frozen surface, containing more water than all of Earth's oceans combined. The presence of liquid water, combined with the energy provided by Jupiter's intense gravitational forces, makes Europa one of the most likely places in our solar system to host life. NASA's upcoming Europa Clipper mission aims to study this fascinating world in detail. The spacecraft will make multiple close flybys of Europa, using a suite of instruments to peer beneath the ice and study the moon's potential habitability. Who knows what strange forms of life might lurk in the dark European depths? Similarly, Saturn's moon Enceladus has captured the imagination of scientists and the public alike. This small, icy world is home to gigantic geysers that shoot plumes of water ice into space. These plumes, erupting from a subsurface ocean, have been found to contain organic compounds, potential building blocks of life. The exploration of these worlds could revolutionize our understanding of life in the universe. If we find even microbial life on Europa or Enceladus, it would suggest that life might be common throughout the cosmos. This would have profound implications for our search for life on exoplanets and our understanding of our place in the universe. As we push further into space, we'll need to develop new technologies for in situ resource utilization, in other words, living off the land. Future space explorers will need to be able to extract water, oxygen, and building materials from the environments they encounter. This could involve mining asteroids for precious metals, extracting water ice from the poles of the moon or Mars, or even growing food in alien soils. The development of these technologies won't just enable space exploration, it could also have profound impacts here on Earth. Imagine being able to extract clean water from the driest deserts, or grow crops in the most inhospitable environments. The technologies we develop for space could help us solve some of our most pressing terrestrial challenges. But as we look to the future of space exploration, we must also consider the ethical implications of our cosmic endeavors. As we venture into the unknown, we'll need to grapple with difficult questions. How do we ensure that we don't contaminate potentially life-bearing worlds with Earth microbes? If we do encounter alien life, how should we interact with it? And as we develop the capability to alter entire planets through terraforming, how do we decide when and if such actions are justified? These questions highlight the need for international cooperation in space exploration. The challenges we face are too great, and the potential rewards too vast, for any one nation to go it alone. Already, we're seeing unprecedented levels of collaboration in space, from the International Space Station to joint missions to Mars and beyond. As we conclude our journey through the future of space exploration, let's take a moment to reflect on what it all means. Every time we push the boundaries of our knowledge, Every time we reach out to touch the stars, we learn something new, not just about the universe, but about ourselves. We are, as Carl Sagan once said, a way for the cosmos to know itself. The road ahead is long and challenging, but the rewards are beyond imagination. In exploring space, we're not just satisfying our curiosity, we're securing the long-term survival of our species, unlocking new technologies that could transform life on Earth, and perhaps even discovering that we're not alone in the universe. So, the next time you look up at the night sky, remember that you're not just seeing distant points of light. You're seeing future destinations, worlds waiting to be explored, and the vast, uncharted frontier of human discovery. The future of space exploration is bright, and its horizons are limitless. Thank you for joining us on this cosmic journey through the future of space exploration. Remember to like, subscribe, and share your thoughts in the comments below. What aspect of future space exploration excites you the most? What challenges do you think we'll need to overcome? Let us know, and keep your eyes on the stars. Until next time, this is Sci Discovery Chronicles, reminding you that the greatest adventure of all is the quest for knowledge. Ad Astra.